Today is August the 12th, 2017. I thought before I put all this equipment up, I would do some measurements here that I think a number of people might find interesting. What I'm going to do, this is the modest little amplifier, 6V4 push-pull amplifier, and I'm going to give you some absolute voltage measurements. And what we're going to do is this one runs a 5U4, but I've got a number of tubes out here. Here's the 5U4's in it now. Here's a 5R4. Here's a 5V4. Here's the mighty 5AR4. And here's the solid state replacements for those, the 1N1239. What we're going to do is start measuring power supply voltages. Well, I'll open this in a second. Start measuring power supply voltages and not only measure the voltage, the DC voltage, we'll watch how quickly it comes up and see if we exceed any of the power supply capacitor ratings, the electrolytic capacitors in the power supply. All these are rated at 450 volts. First of all, let me show you what this particular power transformer is rated at. Right now I've got the test leads across ground and one side of the secondary. This is the type of power supply it is right here. And right there's the numbers I've already given you. It's 295 volts. 295 volts. We can easily round that up to 300. And this is a 600 volt center tap transformer. But I want you to see that. I'm going to plug it in. There it is. This meter is accurate. I know it's analog and we don't get the satisfaction of all the little digits, but we also don't have to watch them bounce around. That measures 290 volts right now. But we're going to call it, you can call it 290, you can call it 295, you can call it 300. I call it a 600 volt center tap transformer. Okay, so now that we've got that established, what we're going to do is I'm going to unplug it again, let it cool down, and I'm going to move this probe right here, and we're just going to start measuring DC at this point right here. Right here. We want to know what the DC is. We know what our secondary voltage is, 600 volt center tap, with a 5U4, 5R4, 5V4, and 5AR4, and a solid state rectifier. We want to know what our voltage is right here. And we want to know how quickly it comes up too, and if we ever exceed the voltage rating of these electrolytic capacitors. It'll also give you a real world numbers of whatever the voltage we get out here. You can use this to reasonably determine what you're going to get out of your transformer by whatever the ratio of this transformer is to yours. So I hope it can provide some help for those people that might need that kind of data also. Okay, let me flip it over here and we'll get started. Okay, let's get started. The tube is cool. Everything is at room temperature. If you can read that, it says that tube is about 80 degrees, depending on where I shine it on the tube. That's pretty much room temperature in here. Well, it's about 76 degrees in here. But anyway, let's power it up. We're going to be watching this meter over here. This is set to DC. And it's on the 1200 volt scale. You should be able to read this quite accurately. We're going to watch it and see how quickly the voltage comes up and what it comes up to. And then we're going to record that. And then we'll move on to the next tube. Okay. Well, it took it a few seconds to warm up. And the voltage rose slowly. It did not peak upward and then come back down very much. Well, it's coming back down slightly, or so slightly as the load increases on it. But on the 1200 volt scale, 864, that's about 300 and I've got to get my fat head in the way here. That's about 330 volts. 330. So we're going to write down 330. And then we're going to measure quickly the power output on this amplifier. just its THD, up to about 1%. Let me stop it here till I get set up. Okay, we can clearly see that that's just a hair under 340 volts. We can call it that. And then let's look at the power over here that this thing does. We're going to repeat this 4 times. Okay, much like I've been doing in my other videos recently. We're going to be looking at these 2 scales right here. This is THC of 1.2%. Let's lower it just a little bit. There's 1% at 8.2 watts. Okay, that's one of our measurements. 8.2 watts. Now let's change it to another one. Okay, now we have a cold 5R4 in there, and we're going to, well, darn, no, I didn't do that. I didn't do that. I pulled the rectifier out and plugged it in. Well, I'm going to record this anyway so that I don't have to do this so many times. We didn't see how quickly it came up, but I'm going to assume it was about the same. And there's our voltage on it. It looks like it's about 320, so it's just a tiny bit less. So it's about 320 volts. And if we zoom in over here and we look at our 2 numbers again, well, our distortion went up quite a bit. Lowering the voltage just a little bit, even that 20 volts, look what it went up to. Let's lower it back down to about 1%. It dropped to 7.25 watts. I'm writing all this down. And then we'll go over it in a second. Okay, now without changing anything, without even shutting the camera off, what I'm going to do is, hot-wise, I'm going to pull out this guy right here and plug in a 5V4. You'll just have to trust me on that, and we're going to watch the meter. Of course, the meter's going to drop off to 0. It's okay to pull the rectifier out. Don't pull your other tubes out while the power's on, but you can do it with a rectifier. So when I pull this thing out, it's going to drop to nothing. And there we go. Now this is the 5V4. It's an old Heath kit, been around 50 years or so probably. Let's see how long it takes it to come up. Okay, right now it's plugged in. I think it's going to warm up a bit slower, but it's going to provide, wow, a lot slower, huh? Comes up a lot slower. But I think we're going to get a bit more voltage out of it. I'll zoom out and let you see what that one looks like while everything is stabilizing. See, there's the 5V4 in it. Okay, so we're not exceeding anything. But let's see what our voltage is now. Sometimes I can see it almost better in the camera. Yeah, it's just, oh, I don't know, I'd call that 341 or 2 volts. Just a couple of volts higher. Didn't make a lot of difference from the 5U4. Maybe 5 or 6 volts. Okay. Now let's look at our power and THD. Well, our power is 7.46. Our THD dropped to 0.5%. Let's run it back up to 1%. Very slowly. We got 8.37 watts. Okay, 8.37 watts. At about 340 volts. Okay. Now let's do the 5AR4. I'm going to put it back on. I'm going to pull this 5V4 out, and we're going to watch the meter climb as we switch rectifiers here. We're doing all this hot. That's okay. think we're going to get even a little more power out of this one. These things get hot pretty darn quick, I'll tell you that. Okay, right now it's plugged in. See how long it takes it to warm up. Well, one of the things I'm noticing is there is no overshoot. If the whole amplifier was cold, you know, there's so many things I want to do and document, but we'd have to let this thing turn off and cool down each time. You know, the rectifiers that warm up quickly, especially when we go to solid state, it's going to be instantaneous. When they warm up quickly, the voltage and the tubes that put a load on it, like the output tubes, if they're cold, what's going to happen is the voltage is going to rise up a little bit past that. And then as the output tubes start drawing heavier current, it's going to drop back down. We're not experiencing that because our tubes are always hot. Okay, now our voltage has risen to 360 volts. 360. Let's see what our power is now. Our power and our THD, there it is. Okay, we've dropped to 0.5% again up here, 0.6 to 8.52. Let's raise this THD up to 1% again. There we go. 9.11 watts. .360 volts. Okay. And last but not least, I'm going to pull out the 5AR4 and put in one of these guys. See, this is called a, let's see down here, a 1N1239. Got a, maybe, I guess it was made for the FAA back in the 26th month of 1972. If that's what that actually means. Okay, let's do this one now. This one's going to come up instantly. Sorry for the fumbling, but I want to get it right on 360. Is that still 360? Yeah, it's pretty much smacked on 360. I guess this is why yesterday when I was working this amplifier, I was thinking it was a 10 watter. Okay, when I plug this guy in, it's going to be instantly, poof, right there. Just like that. And if we read that one, we get just a hair less than 380. We call it 378 volts. Seems like every time we do this, our THD drops to about 0.5% at whatever the power was. We will have to do one more measurement after this. Okay, now we got 9.3 watts at 0.5%. If we crank this guy up to 1% again, I believe I'm going to have my 10 watt amplifier back. Look, 10.14 watts. At 1%, 10.14. Okay, well, I find all this stuff pretty interesting. Let's look over here at the data sheet. There we are. There it is recorded. The 5E4 gave us 330 volts and 8 watts, 8.2. 5R4 gave us actually a little bit less, 7.25 watts. The 5V4 gave us 340, 8.37. The 5AR4 360 at 9.11. And the solid state device gave us 378 volts at 10.14 watts. All this is at 1% THD. And all this is from a 600 volt center tap transformer. This is the power transformer right here, and there's the solid state rectifier in there. Now I think there is one thing we're going to have to do. Shut the camera off, let everything cool down, and with these tubes right here cool, we're going to have to see what the overshoot is. We know that it's going to settle in about 378 to 380 volts, but we want to see how far it overshoots, and it will when they're cold, because it's going to, the high voltage is going to come on instantly. By the way, I do have a thermal resistor in series with the primary of this transformer. I almost always do that. It's probably about a 5 or 6 ohm. You know, once they're 5 or 6 ohms, they limit the inrush current, and then once they get hot, they drop to a fraction of an ohm, and they don't affect it anymore. But if you actually use vacuum tube rectifiers, you generally don't need inrush current limiting into your power supply primary. But if you use solid state ones, you really should, because otherwise the capacitors that this thing is trying to charge appear instantaneously as a short circuit, and you're very likely to start blowing fuses. Let me say something else about the 5U4, 5R4 world. The 5U4, we know, has been around a long time. It takes a 5 volt, 3 amp filament. It is rated at a higher current level than the 5R4. But the 5R4 has a 5 volt, 2 amp filament, and it is rated at a higher voltage than this one. The perfect example of where these two guys are used is in the Collins S-line power supply. It's called a 516F2 power supply. They use this in the low voltage section and this one in the high voltage section. And I've done this before because I thought it didn't really make any difference. But if you put a 5U4 where this one's supposed to go, not every time, but when you least expect it and whenever it wants to, you're very likely to get a flash over in this one if you put it in the high voltage socket. So if it calls for a 5R4, it's probably because the voltage is high. That's the difference between these two guys. Higher current, lower voltage. Higher voltage, lower current. Okay, let's let this thing cool down really good, and then we'll see what our overshoot is with this solid state rectifier. That'll be the worst case. Okay, things are pretty well cooled down. Had that fan blowing on it for a number of minutes now. It looks like everything's about 78 degrees. The tubes, especially the output tubes. Okay, let's get back to measuring. Now, what we're gonna see this time, we're gonna be scoped in on the meter again, and we're gonna see how much overshoot there is. And I think that this analog meter is actually going to do a better job than a digital meter with all that flashing around. Excuse me for, I want to get this thing just right. That looks good. Okay, when we plug it in, we're going to have instantaneous high voltage. And I don't know what it's going to rise to. We know it settles in right at 370 to 380 volts. So let's see. I'm going to get up here quickly. I may end up having to view the video myself to actually get it. Let's see what it does here. It actually didn't overshoot. Not very much. Maybe up to 400. We'll have to, I can get my head in the way this is plugged in. It didn't overshoot very much. Well, there you go. That kind of settles that, doesn't it? Well, okay. That's that. That's pretty much the end of the little project. And we got our we look over here, since I didn't touch anything else, we got our 10 watts back at our let's see, where are we at now? There's our 10 watts right there in the blue, and there's our THD up there, just under 1%. Well, okay. For the experienced people, I don't think that there's anything else that needs to be said. For those of you that are new to the amplifier and electronics world, what I believe you can also use this video for somewhat is, let's suppose you want to know pretty much what your output voltage is going to be. We can use any of these. It's 300 volts. We're going to call it 300 volts just to keep it simple. Excuse me, I got to get over here and get my calculator. We're going to call it 300 volts. We'll call it 295. Calculators make everything easier. Let's say we're going to use the solid state rectifiers. In my opinion, that's the way to go. But if you want to use vacuum tube rectifiers, so be it. You can use any of these ratios, and what I'm getting at here is if we have a 295 volt, that's across half the secondary. That's from ground to one side, and we get out 378 volts, 378. If we divide that, take the reciprocal of that, that's what our voltage increase is, about 1.28. So you get about a 28% rise. So if this was 100 volts, you would get about 128, and so on. You can do all these ratios. You can also do a ratio of, let's suppose that this is not a 600 volt center tap. Let's call it an 800 volt center tap. You can also do ratios like this, and this will put you pretty close in the ballpark. If you do 600 to 800, take the reciprocal of that, that's 1.33 times. And so what you're going to end up with is about 1.33 times this using these rectifiers. You got to be able to do some of the arithmetic. 378 times. So now you're going to end up with about 504 volts. You're going to end up with 500 volts. You're not going to get exactly 504.0000 volts. Hope you understand that. This is probably going to be plus or minus 5%. And 5% of 500 is 25 volts. So that means it could run anywhere between 475 and 525. But these are ratios. This is a real life breathing example of a simple full wave pi network type of power supply that you can use these numbers and these ratios and the ratio of your transformers to this one and come out with a pretty good answer. So the 600 volt center tap one gives you about 380 volts. An 800 volt center tap one would give you about 500 volts, and so on. So I hope this helps. I have fun doing these. I love sharing this. If I do all this in a vacuum, and no matter what I learn out here by myself, if I don't share it, then I'm not sure I've accomplished much. And besides that, when I post these things, you guys make a lot of comments and inject a lot of your own knowledge, and I learn something every time. So thanks for watching. I hope this is valuable in some way. Stay safe. I do want to throw in one more thing. This is the little analog discovery 2 that I bought sometime ago, not too long ago, a couple of months back or so. And this is the FFT function in it. Now, this is not the prettiest thing in the world, and the low frequencies are just horrible, absolutely unusable. But once this is a kilohertz, and there's all of its harmonic. That's the harmonic profile of this amplifier running with a solid state rectifier in it at 10 watts. And what I like about this one is if you set the scale to about 80 dB and about minus 10 up here at the top, I believe, yeah, minus 10, then you can actually get quite a nice display, and I believe it's fairly accurate because the bandwidth of the input channels is good to at least 10 megahertz. Whereas if you use these little USB sound cards, they obviously are don't go that high because they're not meant to go that high. They don't need to go that high. They start rolling off pretty quickly at 10 kilohertz and above. They probably have rolled off significantly at 15 kilohertz, and at 20 they're probably down, I don't know what they're down, I don't even want to say, but they're down quite a bit. So to make accurate measurements, you need a device that has an input bandwidth that's pretty high, and this is pretty high. Now I have found it not very useful for up in the 30 megahertz range. I think they claim it'll go that high, but I don't find it useful up there. But I certainly find this little thing very useful for audio work, so I'm not selling them or exactly promoting them, but I do. Those are my compliments to it, and it has an excellent signal generator output on it. So there you go, and an oscilloscope. So there you go. I thought I'd throw that in case you guys want to, have the need for some of the tools that are really necessary to make these kinds of measurements on audio equipment. Okay, well, I'm going to post one more thing. This is the old Gothic Mark III, a very popular amplifier, very well-performing amplifier. I've shown this in a lot of my videos. What I've done is I've replaced a 5AR4 that's normally in there. Let's see, it's one of these around here. I got a couple of them. I think it was this one. Doesn't really matter. With the solid-state rectifier, the 1N1239. And the reason I'm doing this is, for the same reasons that we did the others, to see what the voltage comes up to. I want to see what it really jumps up to, the DC voltage. This has got a standard full wave rectified type of power supply in it, like this. I didn't draw the primary and everything, but here's the tube, or the diodes, however you want to look at it, into a pi network. We're going to be looking into voltage right here. The voltage on this one, the voltage on that one are essentially the same. There's very little voltage drop across this choke. Okay, so we're going to see what it is. And these kinds of things get discussed oftentimes in forums, and why not just measure it and see how it turns out and put all the guesswork. So let's scope back in on the meter. Get very focused on that. We want to see what this thing jumps up to, what the DC voltage quickly rises to when we turn it on, and then we'll make a couple of measurements and with the solid state rectifier in there, and see what kind of really maximum power we can get out of this thing with solid state, and what the voltages are and all that kind of stuff. The same kinds of things we did in the other one. Okay, let's see. It's plugged in. All I have to do is flip the switch right here on, and we should have it. There it is. I'm not going to put my head in the way. That looks like to me just a little bit over, a little bit over 500. So it doesn't look like it exceeded it to me, from what I can see, and it's going to drop as the tubes warm up. And those KT88s or 6550s start drawing a pretty heavy current. We're going to see it dropping back down to a safe voltage. So I think the part of the question is if you put solid state rectifiers in one of these, when you first turn it on, does it exceed the rating of the capacitor? Yeah, that looks like to me about 480 volts, just shy of 480 volts. I didn't see what it jumped up to because I wanted to stay out of the way, didn't want to get my head in the way. Okay, about 480 volts. Well, we're going to do it hot, just kind of like we did the other one. And I'm going to pull this rectifier out. It's in there really good. I can only use one hand. Goodness gracious. There we go. Finally got it out. Okay, so the filaments of the tubes are still on, and those KT88s are still conducting, so they're dropping the voltage. Okay, I'm going to plug the 5AR4 back in there, and let's see what it rises to. It's not going to overshoot, that's for sure. Okay, it's plugged in. It'll take it a few seconds to warm up. It should start climbing back up. It warms up pretty slow, doesn't it? Actually, quite a bit less, isn't it? Well, no, not really far. That's 460. Only 20 volts. Only about 20 volts difference. So that 5AR4 is, I guess, about the closest thing you can get to a solid-state rectifier and remain a vacuum tube rectifier. Not bad. Okay. I think it's stabilized. I'm going to pull it back out and put the solid-state device back in. Okay. We're back up to our 480 volts or so. Let's see what kind of power this thing puts out. See if there's anything really worth the trouble. Have to examine the video afterwards and see if it actually exceeded the 525 volts. I don't believe it did. Actually, let's see if we eliminate some of the glare. If I unplug this one, it'll get a little bit better. Yeah. Okay. And we'll run our power up until we to the 1% level. All right, 51 watts, 0.3%. And we'll have to crank this down. Let's watch the THD. Let's run it up to 1%. I always find 1% a decent place to stop. 1.8. A bit more. When it wants to jump, it's probably starting to clip kind of heavy there at that point. Yeah, well, it wants to fly between the two. 1.2. Just can't control it. I can't control it that well. I need a finer control there. We're going to stop right there at 55 watts. 55 watts. Right at 1%. Okay. With it cranking, we're going to pull the rectifier out. Boy, that thing is in there good, but anyway, won't we use two hands to deal with that? I like to stay alive. Okay, put the 5AR4 in there. Let's see what kind of power difference we get without touching anything else. Giving it just a little bit of time to warm up and stabilize. We may have to touch up on the drive ever so slightly. Of course, our THC is going to be really high until it warms up nicely. Looks like we're overdriving it ever a little bit. 51 watts at about 3%. Okay, let's turn the volume down to 1%. 2. There we go. 49.88 watts. Call it 50 watts. So you get 5 more watts. And if the diode exceeded the rating of the capacitor, it was only momentary, I believe. Again, I'll have to examine the video closely. So it looks like, at least in mine, you can replace that 5AR4 with a solid-state rectifier without doing any serious harm. Now, whether you want to do it in yours or not, your decision. It'll be your problem. Don't blame me one way or the other. If it turns out good, then it's all to your credit. If it turns out bad, well, there you go. But I've just seen this amplifier discussed a number of times of whether or not to put solid-state rectifiers in there. And this is one example, documented for what it's worth. Now, with this thing operating, let's do this. Let's unplug it. We're going to leave the 5AR4 in it. And we've got 468 volts. I'm going to write down 468 volts. And we're going to very carefully turn this thing over. Not in any way get shocked. Left hand behind my back. Pinch this guy off. Then we're going to put this over at AC. And we're going to measure across half the transformer. Turn it off. Yeah, blue fuse. Darn sure shut off. Well, let's fix it and see what the voltage is going to be. Okay, we're back in business. This thing actually has a broken power cord. The power cord is actually broken right at the amplifier. But I've got it wiggled into place right now, so we shouldn't have a problem. I want to go ahead and finish this. We want to see what our voltage is across the transformer. We know that we got 468 volts out of it, and there is our AC voltage. And reading it here from the camera monitor, it looks like that's I'd call that 390 volts. So 390, that ratio of 390 to 468 is 390, 468. That's if the camera will focus on this. That's a ratio of about 1.2. So we've got about 1.2 times the half the primary voltage. And the other one, we had 1.28. So there again, it goes back to that old general statement of about 1 1/4, about 1.25. So those are real examples of the real world. This is our AC voltage on half of the primary, 390 volts from here to here, 390 volts from here to here. So that's about an 800 volt center tap transformer right at it. And we get about 470 volts out. This ratio is 1.2. This is 1.2 times this. So if you've got 400 volts there, remember in the other one we did 400 instead of 390, and we got 500. But we estimated that at 1.28. Well, in this case, it's 1.2. So we've got two examples here, 1.2 and 1.28. So again, 1.25 is a very good and reasonable starting point. And now I've got to fix it. Well, here's what's wrong with this thing. I kept looking at it. I said, is there something, what's going on with this thing? But it's broken right here. I wiggle it right there, or push, twist, whatever, comes on and goes off. So Right there where it flexes, it's bad. I guess what I'll have to do is pull the string relief out and maybe just cut off a couple of inches of it and slide it right in so I can retain the same power cord. This is a good power cord, even though it's really, really old. The old Macintosh equipment has these types of soft rubber power cords on them too. So there you go. Hope this helps.